Hello and welcome to this learning video. In this learning video, we are going to take a problem on half-range sine series with a different variety of example. One variety we have already seen in the last learning video, and here in this second learning video, we are going to take even a better problem for half-range sine series. Okay, so let us say what this problem says. This problem says represent the following function by a Fourier sine series. Represent the following function by a Fourier sine series. Now don't get confused because here the interval is very important. What is the interval? 0 to pi. So by looking at this, you should realize or you should take a decision that this problem is of Fourier half range sine series. Sine series, it's already there. Okay, so let us solve this problem. So how one can start with this problem? So we start with this problem by letting the given function. Let f of x is equal to, what is it? X 0 less than equal to x less than equal to pi by 2, and the another one is pi by 2 for pi by 2 less than x less than equal to pi. Okay, so this is the given function. Say this is to be 1 and write down the required Fourier series. So here you can write the required Fourier series. The required Fourier series is, so what is the required Fourier series? Can you able to write it? Yes, f of x is equal to required Fourier sine series, to be precise, is f of x is equal to summation n is equal to 1 to infinity bn into sine n pi x by l. So l is equal to pi, so you can directly write n x. This is my required Fourier sine series, where what is bn? Where bn is equal to, what it should be? Where bn is 2 by pi integration 0 to pi f of x into sine nx dx. Simple. Now let us find out this bn, which is very easy. To find bn, so what is bn? Bn is this. Bn is equal to 2 by pi. Now here, as you can see, my f of x is given in the range 0 to pi by 2 and pi by 2 to pi. So I'm gonna break this interval 0 to pi as integral 0 to pi by 2 f of x into sine nx dx plus integration this pi by 2 to pi f of x into sine nx dx. Simple. Now you can see here, this is like 2 by pi integration 0 to pi by 2. What is my f of x in 0 to pi by 2? X. So let us write it as x into sine nx dx plus, in the interval pi by 2 to pi, my f of x is pi by 2. So just writing this pi by 2 into sine nx dx. Now as you can see here, in the first integral you have to apply what? You have to apply integration by parts, and in second you just have to take the integration of sine x. Okay, so let me write it now here. Bn is equal to 2 by pi, applying integration by parts over here. So this is first function, integration of sine nx is minus cos nx divided by the coefficient of x, that is n, 0 to pi by 2 minus derivative of first, that is 1, and then integration of this. So what is integration of this? Integration of this is, let me use another bracket, some different kind of bracket. Yeah. So what is integration of this? Minus sign as it is, n as it is, derivative of cos s, sine nx by n. So this become n square, 0 to pi by 2. Okay. This completes integration of this first term. Now integration of this. So this is plus pi by 2 outside. Integration of sine is minus cos nx by n, limits pi by 2 to pi. Now apply the upper limits minus lower limit. So what is it? This is 2 by pi. What is what is upper limit? Upper limit is pi by 2. Here cos n pi by 2. Cos n pi by 2 is 0, and lower limit 0 into anything 0. So the first term will contribute to 0. This minus minus become plus, 1 by n square outside. Applying the limit, so this is sine n pi by 2. Sine n pi by 2 minus sine 0 is 0. No need to write. This is minus pi by 2. Minus pi by 2 n cos n pi. This is cos n pi, upper limit, minus lower limit is cos n pi by 2, that's 0. Simple. So as you can see here, now you can able to write down the value of Bn. So what is my Bn? So my Bn is 2 pi n square. This implies Bn is equal to 2 pi n square. 2 pi n square sine n pi by 2. So you can substitute sine n pi by 2. We don't have value for sine n pi by 2. It may be plus, if n is equal to 1, pi by 2, then it is, if n is equal to 1, that is 1. If n is equal to 2, it's 0. So 2 get cancelled, sine pi is 0. If n is equal to 3, 3 pi by 2 minus 1. That's why I'm writing it is as it is, sine n pi by 2. Okay, clear? Then this is, this 2 by pi by 2 get cancelled, so we remain with minus 1 by n, and cos n pi is minus 1 to the power n. It's minus 1 to the power n. Okay, cos n pi is minus 1 to the power n, cos sin n pi by 2 is sin n pi by 2, because it gets different values for n is equal to 1, 2, 3 and so on. Okay, so what is my required Fourier series? You can write here, putting these values in equation 2, we get, putting these values in 2, we get, so what we get? We get f of x is equal to, substitute there, f of x is equal into, we get f of x is equal to summation n is equal to 1 to infinity Bn. What is my Bn? This 2 pi n square into sine n pi by 2 minus 1 power n upon n. This is Bn into sine nx. And this is the required, Fourier series for the given function the given function in 0 to pi. And this completes the solution of this problem. So I hope this is clear to you. In the earlier video we have taken a different variety of problem, and here we have taken another problem where two functional values are given to you for the given function. Earlier it was just of one function. So we have taken two different variety of problem on this. In the very next learning video we are going to take a problem on half range cosine series. Okay, and there is one interesting problem that I'm going to take in the very next learning video. So thank you for watching this learning video and enjoy learning mathematics. Thank you.